Buenas tardes, bienvenidos y bienvenidas al Marisur Metáforas. Es un gran honor tener a Ricardo Padrón aquí. Ricardo Padrón es profesor de español en la Universidad de Virginia, donde ha sido miembro de la facultad por más de 20 años.
27 años.
27. Completó su doctorado en la Universidad de Harvard y su maestría en la Universidad de Chicago. Profesor Padrón estudia la literatura y la cultura del mundo hispánico, en particular las cuestiones del imperio y el espacio, en la cartografía y la imaginación geopolítica del mundo moderno temprano. Su reciente libro, The Indies of the Setting Sun, con la Universidad de Chicago, examina el lugar del Pacífico y el Asia en el concepto español de las Indias. Y el profesor Padrón es un miembro activo de la Renaissance Society of America y actualmente se desempeña como miembro de su junta directiva. Muchísimas gracias por llegar a California y venir.
Yeah, thank you. I'm going to speak in English. So, gracias, Jimena. Just of course, but if I'm talking to me, Jimena has come out in Spanish. Gracias. Jimena is a wonderful, wonderful hostess. It's such a pleasure to be here at UCLA. And I'm sure, as most of you know, this Mari Sus Metáforas is totally her baby. She does all the work. And it's been really visible. So thank you for everything you're doing to put this series together. And thanks to the Department of Spanish and Portuguese and the people who made it possible for me to come. So there's one person in the audience, Barbara, who is going to recognize a lot of what I said here, because in a way this talk is actually going back to the article that you had published in Hispanic Review and sort of rethinking about this. So I work on this thing called the Spanish Pacific. And without getting too involved in what this means, it really means this space that is created when the Spanish managed to extend their empire across the Pacific from the Americas to the Philippines. And so this got me really involved in questions of how the Pacific was explored, how it was mapped, how it was conceptualized, and that's what I'm going to talk about today. So today is going to be a little visit into what it means or what it meant in the 16th century to explore and to come to know new spaces, right? Because if we look at sort of an older sort of version of this historiography, historians were always interested in the progress of knowledge, And so discovery was understood as the process by which Europeans encountered places that they didn't know, map them, and so knowledge would improve and maps would get better. And what I want to do is I want to talk today about what an unbelievably messy process that actually was. And we're going to take this idea of a linear process in the creation of knowledge through the process of something called discovery, and we're going to take this apart. So the topic today is the Pacific Ocean. So the Pacific Ocean, this is an image from Google Earth. What I did was I centered Google Earth on the island of Tahiti, and I zoomed out. And it gives you an idea of just how large the Pacific Ocean is, because you notice there's no land in this image. There's some of Antarctica here, covered with clouds. There's a tiny bit of California and Baja California on the left. Asia is barely visible on the top. But so the Pacific occupies something like 2/3 of the world's oceanic space, and it's what makes the world look like this blue marble. It's absolutely that large. The first inhabitants of the Pacific, the first human inhabitants, were people who populated it over this sort of very long process of migration. They started in Southeast Asia, and then in sort of different waves went out to these various islands throughout the Pacific. One of the last places reached was New Zealand. And this process came with incredibly sophisticated technologies. Traditional Polynesian navigation is the best navigation, the most accurate navigation of the pre-modern world. Polynesians were able to locate and visit tiny islands in the middle of an ocean with the kind of skill and accuracy that Europeans would not have until the 18th century. So I want to acknowledge this, that there's a very deep history to the human habitation of the Pacific that goes back thousands of years, and it is primarily the story of non-Europeans. But that's not the story that we're going to tell today. We're going to talk about this European experience with the Pacific. And what we have to understand is that for Europeans, during the time of the so-called Age of Discovery, Columbus, da Gama, Magellan, these people, the Pacific was actually inconceivable. So that picture that we just saw, in which a large part of the Earth is covered by ocean, and it's possible to pivot the globe so that the land isn't even visible, it was impossible, practically impossible, for Europeans of the 16th century to picture the world that way. Okay, so this is where we have to reach into the past and put our medieval nerd hat on, right? We're looking at two maps here. Each of these maps tells us something about the way that Westerners imagined the world during the Middle Ages. This first map is a map of the known world, obviously a schematic map. You'll see that the world is basically an island divided into three parts: Asia, Africa, and Europe, surrounded by ocean, right? And there are schematic images from the Middle Ages of the world that looks like this. There are more complicated ones. But what we're looking at here is we're looking at what medieval intellectuals would have called the orbis terrarum, or the oikumene. So a Latin word and a Greek word for the part of the world that is inhabited by human beings, right? The other map, these are all printed versions, so they're 15th century versions of maps with a long manuscript tradition going, long before the publication of these. The other map is a depiction of the entire globe. So this is a depiction of basically a very large island where human beings live. And this is a map that helps us to imagine the place of that island on the globe. So you'll see that Africa, Europe, and Asia are in this top island. And the map depicts the rest of the terraqueous globe and allows us to ask the question, are there other such islands, right? And so the Greeks, the Romans, the Middle Ages, all tried to wonder, okay, so if the oikumene is here, is it possible that there could be other such islands in the southern hemisphere? Could there be another island on the opposite side of the northern hemisphere? The conclusion reached by St. Augustine of Hippo was no. There could not, for theological reasons that we need not get into. The idea was there was only one island, right? The short and skinny is, according to the Bible, all human beings are descended from Adam and Eve. And so if there were other islands in places that cannot be reached, how did human beings get there? If you can't have human beings, Augustine says, well, God would never have created land that wasn't useful to human beings, and so the land must not be there. So the standard story in the Middle Ages is there's only one island. But then the question becomes, how big is the island relative to the rest of the globe? In other words, does the land really cover it, or is it a mixture of land and sea? And some people insisted on a small island relative to a large globe. The people who told Columbus that we was wrong. How many people were once taught that Columbus proved the world was round? Did you ever have a teacher tell you that? You heard that? Did anyone else hear that? Okay. It's not true. It's not true. Everyone in Columbus's time knew that the world was round, right? But the question was, how big was that island? Because if the island was big, you could get from one side to the other, sort of around the back side of the world. If the island was small, the trip was too long. You'd die along the way. The people who said no to Columbus were this small island group. It's too big. But people like Columbus, or rather Columbus and people like him, imagined the world in a different way. This is the first globe that we have from the early modern period by a German named Martin Behem. What we're going to do, since you can't really see a globe on slides, what we're going to do is going to work with this map, which is made by an artist who has sort of taken that globe and flattened it out, right? So what we're looking at here is the map of the world on this globe as if it were flattened out. And here we have Europe, Africa, and Asia. But notice how much space it takes up. This is the rival group. This is the large island group. This is the kind of thinking that allows Columbus to believe, and what we're going to do is we're going to change it so we have the Atlantic Ocean in the middle, right? This large island allows you to imagine, notice the little boats, that you can sail from here to here without starving to death along the way. This is the island that Marco Polo called Cipango and that we better know as Japan. So this is what the world looks like to a lot of people in the late 15th century. A gigantic island, which is the known world, with a fair amount of ocean, but certainly not enough ocean for there to be a new world in here, much less a gigantic Pacific Ocean between here and the new world. There's just no space for it. No space for either America or the Pacific. This idea persists. This is the most expensive map in the world. It's a huge map. How much do you think, if I say the most expensive map in the world, what's the number that pops into your head? Anyone want to guess? What would the Library of Congress pay for a map which has the distinction of being the first document to call the New World America? What? $15 million. $15 million for this map and for its companion. There's only one copy that has survived in the world. That's why it's the most expensive map in the world. Called, the word America appears here. But look at what's going on with America. I'm going to zoom in on this little inset. We've managed to squeeze in the New World in that narrow ocean between Spain and China, between Spain and Japan. But not a lot of room left for a gigantic ocean between the Americas and Japan. So what I've done is I've measured the degrees of, this is the equator down here. It's only 40 degrees of longitude between the westernmost part of South America and the latitude where we find the island of Japan. I want you to keep that number in mind. 40 degrees of longitude. We all know that the whole way around the world is 360 degrees of longitude. So this is a small portion of the circumference of the Earth. Okay, so what happens? When Europeans first cross the Pacific, they are expecting that short distance. You know, Magellan. Do you remember Ferdinand Magellan? Ferdinand Magellan, his expedition was the first to make it all the way around the world, but he actually died along the way. The objective was to do what Columbus had tried to do, but had failed to do. Magellan says, I know how to get from Europe to the east by sailing west. We're going to do it by sailing around South America rather than straight across, which was Columbus's project. He discovers the Strait of Magellan, discovers that passage that's going to take him from the Atlantic to the Pacific. And at that point, everyone in the expedition is overjoyed because they think that it's going to take maybe 2 weeks to reach the Spice Islands. It actually takes more than 3 months, right? And so the description of this voyage from an eyewitness is about this absolutely hellish crossing in which they are reduced to eating the leather off the rigging, making food out of the sawdust. And whenever anyone could find a rat on board, they could sell that rat for like a king's fortune. So they're starving. They are suffering from scurvy and other diseases. The only reason that they're not dying of thirst is because there's rain. So there's plenty of rainwater, and that's the only thing that keeps them alive. So Magellan comes back, and these maps that are produced after he comes back, all of a sudden, remember that 40-degree difference between South America and Japan? That becomes a 140-degree difference. So all of a sudden, boom, this enormous space has opened up. We know from Magellan's experience that a lot of it is ocean. Some of it may be land, north and south of the line Magellan sailed, nobody knows, right? This is still short of the true value. So the true value for this distance that I'm constantly going to show on these maps is 150 degrees of longitude. Now, this is the weird thing that happens. We would expect that once Europeans know that there's this huge ocean separating the Americas from Asia, roughly 140 degrees of longitude, we would expect that number, that distance, to sort of like remain in future maps, perhaps get more accurate, perhaps approach that true value of 150 degrees. But on Spanish maps, on maps made by Spain, the number actually gets smaller. So here's a world map from 1544. This is 20 years after Magellan. 90 degrees for that same distance. Then we go to another Spanish map, this one from 1602. So now we're talking about 70 years after Magellan. It's grown a little bit. It's not 90, it's gone up to 120, but it's still short of that 140. Statistically speaking, these are huge variations in this distance. The Pacific is doing this on this map, and the question is why? And when we start to answer the question why, that's when we start figuring out what a messy process discovery and mapping actually is. So I'm going to give you a series of explanations for why this happens. And what you're going to see is that the explanations are not at all incompatible. First one, the persistence of tradition. I told you before that these explorers are going out into the world with a model of the universe that tells them that the globe should be more land than water, right? And there are a lot of reasons why they don't want to give up on this idea. So what happens? We see maps that simply erase the Pacific. So for example, in this one, done 3 years after Magellan returns from his voyage, here's South America, and you'll notice that it connects directly to Asia. So what was the ocean that Magellan was saying? It wasn't the Pacific Ocean at all, because there is no Pacific Ocean on the map. The ocean to the west of South America is the Indian Ocean, right? So this is how we make room for Magellan's discoveries while still maintaining this one large islet, on which people live. This persists. 1565, here's another map doing the same thing, uniting America and Asia into one large continent, and then introducing this hypothetical continent in the south that fills in a lot of the space. Here, just 105 degrees of difference. The first ever printed map of the Pacific Ocean in 1589. Our Pacific gets a little longer, considerably longer, 135 degrees of longitude. But notice how this hypothetical continent and this inflated New Guinea fill up the space, In other words, these maps are never going to give us that blue marble vision of the world, because they're always going to fill up unknown ocean with unknown land. So that's our first explanation. The persistence of this idea that the world must be more land than water. Second one. I've given this the title of a friend of mine, a historian, talks about cartographic chicanery. And I really wish I had come up with this word, because I love the word chicanery and I would have loved to have used it in print. You guys might remember that the Spanish and Portuguese empires divided the world between them along a series of lines, right? So the original line, the Treaty of Tordesillas, said that everything in this direction was Portuguese and everything in this direction was Spanish. But what happened when the Spanish and the Portuguese went around the world and met on the other side? They had to negotiate the presence of the line on the other side of the world. This map maps it as well as you can on a modern map of the world. And you'll see that the line falls here, so that the Philippines, the Spice Islands, Japan, China, Vietnam, all of this is in Portuguese territory. What do the Spanish do? They map the world in ways that give them the Spice Islands. So we saw this map. This is the first map to give us a big Pacific, right? A long Pacific, a broad distance. What we also know about this map is, yes, it tells us, yes, this Pacific's way larger. This ocean is way larger than we thought it was, but it's not that large. It's just small enough so that the Spice Islands appear in the Spanish side of the line. This map was prepared by royal map makers and was given to Italian aristocrats as part of a propaganda campaign that was launched by the Spanish crown to control the spin around the Magellan expedition. You know, the Spanish crown could not get the news out there. They couldn't allow for the news to go out about the true breadth of the Pacific or about the difficulty in crossing it. So they produced maps that gave you a big Pacific, but not too big a Pacific. They gave an official account of the Magellan expedition. Remember of that story I told you about eating the rigging and the sawdust and the rats? In the official account, none of those details appear. Instead, the Magellan expedition finds a little island where they can fish and have a nice time on the way across the Pacific. No admission about how hard the crossing actually was. And this propaganda effort continues through the rest of the 16th century. When we look at some of these other maps that we've seen, you know, what does it do? Why do you get that shrinking Pacific? Because it gives more of Asia to the Spanish. So we saw on that modern map, China, Japan, Korea, Indonesia, the Philippines, they're all on the Portuguese side of the map. Notice that on these Spanish maps, East Asia is on the Spanish side of the line, not the Portuguese side. So what these maps are doing is they're asserting this Spanish claim to East Asia, saying that East Asia is not East Asia, it's actually the westernmost part of the West Indies. That's what these two maps are saying. So we have the persistence of tradition. We cannot have a big Pacific. We have this political interest in sort of falsifying the maps to make Asia Spanish. And then we have technical limitations. Let's take a look, for example, at the story of this exploration. We have a series of expeditions. I've been talking about Magellan, who sails between 1519 and 22. He's trying to reach the east by sailing west. His biggest accomplishment is that the expedition actually manages to reach the Spice Islands, and so they sort of, you know, they plant the flag and lay a Spanish claim to the Philippines, to the Spice Islands, etc. The Spanish immediately organize a follow-up expedition to try to colonize the places that Magellan had claimed. The result is total disaster. Most of the ships sink, most of the people die, very few people make it home. There are a series of ships that are sent from Mexico to reinforce that expedition in the Spice Islands. Result, disaster. The ships sink, the people die, nobody makes it home. In the 1540s, they try again. They organize an expedition, this time not from Spain, but from Mexico, to conquer the Philippine Islands and establish a Spanish colony. Result, disaster. The ships sink, the people die, very few people make it home. I think nobody makes it home from this one. No, actually, I do know of at least one person. But we're talking about an expedition of 700 people, and the number of people who make it home could probably be counted on two hands. Finally, an expedition in the 1560s succeeds. They managed to colonize the Pacific. Why is all of this so hard? It has to do with the way the Pacific works. If you're crossing an ocean on sailing ships, you can't go just any way you want. You have to find out where are the prevailing winds and the prevailing currents that are going to take you where you want to go. And the Pacific, the North Pacific, moves in this clockwise direction. So what all of these expeditions are doing is they're sailing this way. They're using the equatorial currents and the trade winds to get across the Pacific to the Philippines and the Spice Islands. Why are so many of them ending in disaster? Because the return route is this one. You have to sail very far north, catch these westerlies, and come down the California coast. This is a trip of 3 months. This is a trip of about 5 or 6 months through very stormy seas and very cold temperatures. So all of these expeditions, they're all trying to get back. None of them managed to do it until the last one. The reason that the last expedition is successful is because they managed to get ships back and establish a constant connection. In other words, they can get reinforced, they can get resupplied, they can have contact with a home base, right? Now, what does this have to do with measuring the Pacific? I've been talking a lot about longitude, but this is something that no one had any idea how to measure. Let's review for a bit. You know, a cartographic grid has horizontal lines and vertical lines. The horizontal lines are latitude, so they are my distance north and south of the poles and the equator, expressed in degrees. Latitude is really easy to measure. Any of us with some cardboard can build a little instrument that will allow us to determine the latitude of where we're standing right now. As long as you have clear skies, you can do it, right? Longitude is unbelievably difficult to measure, and nobody knew how to do it in the 16th century. So when I say to you, okay, 140 degrees of longitude, 50 degrees of longitude, how did they figure out the longitude? They figured it out. You're not going to believe this. It involves throwing a piece of wood off of a boat, okay? What they were using was a system called dead reckoning. This was how you measured the speed at which your ship was traveling. So take a look. This is from a book about navigation. So longitude was estimated by dead reckoning. Whenever a caravel or a galleon found itself in open water out of sight of familiar landmarks, the navigator estimated the path of a ship by determining the distance and direction traveled each hour and then adding up all the distance and directions. Dead reckoning was, especially in its early days, a very rough and ready method of estimating location. Okay, but how do you do this? How do you determine distance and direction? I'm on a ship. I'm in the middle of the ocean. I don't have any landmarks against which to measure my progress. What I do is I make a little mark on the railing of my ship, and then at the end, I make another little mark. I have a person standing at the first mark, and he takes like a piece of wood and tosses it into the ocean, turns an hourglass over. And you see how much time, by the hourglass, it takes for the ship to sail past the floating piece of wood. That gives you the speed of the ship. Use your compass to measure the direction. I hope it's clear to everyone that this is a wildly inaccurate method. Wildly inaccurate, you know? And what makes this even more difficult to use is that dead reckoning becomes distorted whenever you have what sailors called following seas, right? So following seas are wonderful sailing conditions. What it means is you have the wind behind you and the current in your favor. So you're just riding along with it. What following seas do is they introduce an error into direct reckoning, a systematic error into direct reckoning. In other words, you are much more likely to overestimate I always have to think about this. I might be getting it wrong. Let's put it this way. You are much more likely to get the speed of your ship wrong. And once you start adding up those errors over the course of the 3-month voyage, you end up with a shorter distance, right? So why do these people, what's one of the reasons why they think the Pacific is narrow? Because they have technology that when you use it in the conditions of a Pacific crossing are likely to produce underestimated results. Over the years, after you have one expedition, these rinse and repeat expeditions, you finally have a bunch of people, a bunch of pilots who've crossed the Pacific on these different expeditions. And all of them have come up with different estimates. Some of them, the good ones, the really good ones, have been able to correct for those errors. And so their guesstimates of distance and direction have been pretty good, and they've come up with pretty good, fairly accurate ideas of the distance crossed. Others weren't good at correcting the errors in the guesstimates, and they come up with different figures. So in the 1560s, the Crown is thinking, okay, let's try again. Let's try again to conquer the Philippines. And they interview a bunch of pilots. And you have Juan Pablo Carrión, who's a veteran of the Villalobos expedition, the one from the 1540s. He's telling the king, the Pacific is relatively small. And as a result, the Philippine Islands are on the Spanish side of the Portuguese line, and it's legitimate to conquer them. But then you have this other guy, Andrés de Urdaneta, who's a veteran of one of the other expeditions. He's saying the Pacific is actually relatively wide. And the Philippines are on the Portuguese side of the line. And so therefore it is not legitimate for Spain to colonize there. Who do you believe? How do you decide? What do you think?
Pick the favorable one.
That's right. Who wins? Juan Pablo Carrión is the winner. Because when you have different technical information and no way of mediating about this, no way of coming to an agreed upon scientific solution about the problem, what are you going to do? You're going to pick the one that gives you the islands. And that is exactly what the King of Spain does. He thinks, we're going to go with this smaller number, we're going to colonize it, and we're going to worry about conflict with the Portuguese afterwards, right? But who does he pick as the pilot for the expedition? He picks him. So the Spanish actually know that he's the better pilot. And what happens is the expedition sails with sealed instructions. So nobody knows what the real destination of the expedition is until they're like several hundred miles off the Mexican coast. And that's when they open up the sealed orders and they find out that the destination is the Philippines. And this guy who has been saying to everyone who will listen, the Philippines are not colonizable by Spain, all of a sudden finds himself piloting the ship to exactly the place that he thinks they shouldn't be going. And they were lucky to have him because he's the one who figures out how to get back, right? So you have technical limitations that intersect with politics. What's our last explanation? This is my favorite explanation, I have to tell you. This is the one that I think is the most fun. Okay, so let's think about our history of expeditions. Disaster, disaster, disaster. The end result of this is that there comes a point when the Pacific is starting to be perceived as an insurmountable boundary. So, for example, this man, St. Francis Xavier, one of the great saints of the Catholic saints of the 16th century, he has a mission in what is now Indonesia. And one of these expeditions, the Villalobos expedition, the survivors end up in his hospital. Legend has it that the captain general of the expedition died in the saint's arms. 14 survivors, they die in this Jesuit hospital. And he writes a friend, tell the King and Queen of Portugal that for the peace of their conscience, they should advise the Emperor, Charles V of Spain, not to send any more expeditions by way of New Spain to discover the Silver Islands, that is Japan, for as many as come will surely be lost. So St. Francis Xavier is writing back to the rich and powerful in Spain and saying, stop doing this. the Pacific is uncrossable. Everyone who tries to cross it is going to end up dead. It's always going to be a disaster. A couple of decades later, in 1562, we get this map of the Americas, and I've always been struck, this is a detail from the map where we get a little piece of the Pacific, and every single one of these ships is in trouble. They're being menaced by sea monsters. There's one that's becalmed. There's another one that's sinking, right? And so in this map, it's depicting what was often called the South Sea rather than the Pacific as this particularly dangerous, unnavigable ocean. So what does this mean? Theory pause here. The philosopher Edward Casey, in his book, Getting Back into Place, makes some really interesting observations about distance and how we perceive distance. So far, I've been talking about distance in terms of numbers. We've talked about degrees of longitude. And you might have realized that what dead reckoning means is that because you can't register longitude, you have to measure distance in miles or leagues. That was the unit that was used. And then convert the leagues into degrees of longitude, right? But when we talk about distances in our lives, we don't talk about that. How far is your home from UCLA? How far is your?
Thousands of miles.
Thousands of miles? How long does it take to get there?
5 hours flying.
See? You give me that number. If I ask you, how far is something? I will put money on it that most of you will tell me how long it takes to get there, right? But how long does it take to get there? 5 hours flying. What if you had to walk? As a friend of mine likes to say, everything is in walking distance if you have enough time, right? So think about this, so here you are, you're in a position to fly back and forth. Where is home, by the way?
DC.
Oh, DC, okay, not far from where I am then. So you're in a position where you actually fly back and forth, right? What if you can't afford to fly? What if you're an unhoused person living on the streets of Los Angeles? What's near or far for that person who obviously can't fly, doesn't have a car, may not even be able to afford the bus, right? So in other words, what Edward Casey is telling us is that our perception of distance is entirely dependent on our ability to negotiate it, to travel it. And what he says is that we have to think about distance in terms of these three domains. And I've made the circles fuzzy because we're talking about very fuzzy boundaries between these domains. We can think of things that are near to us, right? So whatever's near is whatever I can get to without thinking. And it might be as near as this chair or as near as the beach, In other words, the near can be, there's a whole range of possibilities here, but I can get to them without thinking. They're in reach. The far takes more effort. So Casey says, this is what's in reach. This is what I can range to. I have to plan this. I have to expend resources to get to faraway places. So for you, DC is far. You have to buy a plane ticket, you have to schedule it, you have to go to the airport, all this stuff. The distant is whatever you perceive of as being entirely out of reach, right? So the moon for us is distant. Maybe not for Elon Musk, but for us, for me, the moon is distant, right? And notice how this is all relative, right? So if I'm a houseless person living on the streets of Los Angeles, the distant is most of the world. Most of the world is inaccessible to me. If I'm a privileged professor at the University of Virginia, then distant might be, a lot of places that I think I'll probably never get to in life. Sub-Saharan Africa, Mongolia. These places are distant for me because I can't imagine ever going there, right? For Jeff Bezos, maybe there's nothing that's distant because I figure he can go anywhere he wants, right? So what's going on here? My favorite map that I'm going to show you is this one. It is also to use a technical term, the suckiest map, right? Every other map that we've seen up until now was created by someone who knew what they were doing. Someone who had some kind of training, maybe experience as a pilot, some kind of mathematical training, that sort of thing. They were using numbers. The guy who drew this map had no such training. He was a lawyer. He was a lawyer who got promoted to the position of cosmographer of the Indies. So he was the guy who was in charge of sort of taking care of geographical knowledge about the Indies for the Spanish crown. He got this through connections. That's how he ended up with this job. And so he was in charge of producing this map, which was for the consumption, for the use of the king and his ministers, so that they could imagine the Spanish Empire and sort of make policy and make decisions. One of the things that makes it incredibly bad, first of all, there are no numbers. Why have I not given you, a numerical value for this distance? Because there's no grid or latitude and longitude here. It's all it's an impressionistic sketch rather than a technical sort of map. And what I did was I drew an arrow from Acapulco to Manila, because that was the route that connected the Americas to this brand new colony in the Philippines. And I cut and pasted that same arrow into the Atlantic, right? And you can see that visually, the distance here is pretty much the same distance as the distance in the Atlantic, from the Canary Islands to the Caribbean. This line should be 3 or 4 times the size of that line for this to be a quote-unquote accurate map. Why is the Pacific so small here? All of the explanations I've given to you work. For example, this is a person for whom that geographical tradition is important. Notice how most of this part of the map is brown, which indicates that he believes that that hypothetical southern continent that fills up most of the Pacific, it's out there. This is a map that draws the lines defining the borders of the Spanish Empire. And notice where this line is. It's in a place that gives China, Korea, Japan, the Philippines, Indonesia, all to the Spanish, right? So it's invested in this idea that East Asia is Spanish. It's drawn by a person who had access to the logbooks of pilots. So all of those all of that messy data sets that can contribute to making maps smaller, he would have had access to that. But what do I think is the most important thing? It's the fact that a route has been created. Remember what we were saying? St. Francis Xavier says, send no more ships, because as many ships as you send are certain to die, are certain to sink. The Pacific is uncrossable, the Pacific is unnavigable. What has happened between then and the moment this map is drawn? What's happened is we've had that successful expedition. Lopez de Legazpi has sailed from Mexico, has established a colony in the Philippines, and his partner, Andrés de Urdaneta, the guy who thought that he wasn't supposed to be in the Philippines to begin with, has discovered the route back. And what he's done is he's mapped it so that it can be reproduced. And on the basis of Urdaneta's data, the Spanish have set up the first ever commercial route crossing the Pacific on a consistent basis. Every year, at least one ship would sail from Acapulco to Manila and then sail back. And people, goods, ideas, documents, they all traveled with this. So what's happened? For Juan López de Velasco in Madrid, a guy who never left Spain, the guy who's drawing this map, what I would say is that Asia is no longer in his distant zone. It's in his far zone. It's no longer a place that is on the other side of an incrossable ocean. It's a place at the end of a very long and laborious route of travel. It takes a couple of years to make this whole voyage. But the point is that you can do it. When we talk about the modern world, we talk about, in our world of planes, trains, and automobiles, we talk about something called space-time compression. The idea that DC is only 5 hours from LA. The world is smaller when we have these very efficient, rapid means of transportation. In the 16th century, we have an early version of that. It's not about rapid transportation. It's about connectivity. It's about the fact that connections are being created among places or along routes that didn't exist before. And so for a lot of people, places that were once distant are now only far. And I think that's what this map is saying. It's not saying anything about the real distances, in numbers, in leagues, or in degrees. What it's saying is that Asia is just as accessible from America as America is from Spain. Okay, so now I'm going to wrap this up. So what we've been looking at is at the fact that the process of discovery and mapping is not linear. It's not a matter of getting from ignorance to knowledge, increasingly better knowledge, increasingly better maps. And we've looked at the invention or the reinvention of the Pacific as a messy one that has involved a variety of things. The persistence of models and paradigms that make no room for a ginormous ocean, that insist that the ocean cannot be as big and open as it seems to be. Deliberate falsification of data for political purposes. Poor data sets produced by inadequate technology. And changing perceptions of distance in response to the development of infrastructure and the connections that infrastructure creates. So we can say that the Pacific Ocean was not discovered by Magellan at all, but was rather invented in the European imagination, and specifically in the Spanish imagination, over the course of the 16th century, and actually, if we had more time, into the 17th and 18th century, by the Spanish, and then eventually by the English and the French. So, thanks for your attention. Here's my email if anyone wants to contact me, and if you have questions now, be happy to chat.